today because we are welcoming back an alum, Viviana Márquez. So Viviana currently is the AI community lead at Word2Vec. She earned her master's in data science right here, as said, and has worked as a data scientist at top-tier organizations including HBO, Dataminr, and Royal Caribbean. Beyond her work in industry, Viviana is also a dedicated educator, having trained over 4,000 learners, from graduate students to Fortune 500 teams, by translating complex AI topics into clear, practical skills. So, all that said, join me in welcoming Viviana.
Hi everyone. It works? Yes. Hi everyone. Oh, I love that. Everyone replied. I was thinking of starting this session with a song because I'm Colombian and I love music. So now I kind of regretted that I took it away. But imagine a Shakira song playing just now. So today we are going to talk about how AI learns languages. I love languages, whether it's English, Spanish, Chinese, Russian, Portuguese, whichever one it is. Because it allows us to communicate, to share knowledge. And I also love AI, that's why I did this master's program. So I think it's a really exciting time to be alive if you love languages and AI, because we're seeing the rise of large language models and the huge impact that they're having in society. So that's what we're going to be talking about today, and also because they're having so much of an impact in society, we're going to talk about how we evaluate them. And speaking of things that I love, as Elizabeth mentioned it, I'm really proud to be an alumni from the Masters of Science in Data Science here from the University of San Francisco. So that's a picture of my last day as a student. So it was only 7 years ago that I was where you guys are sitting today. And for those of you that are joining us from an external place today, first of all, welcome. This series happens every Friday. They have different speakers. It's not sponsored, but yeah. And then the program, I was part of cohort number 7, and it was the first cohort where the program was called Masters of Science in Data Science. Before it was called Masters of Science in Analytics to reflect the trends in the industry. And then the program this year is changing its name again to Masters of Science in Data Science and AI. So that's one of the things that I like about the University of San Francisco. It keeps up with the current industry trends. But not only that, but I don't think 7 years was that long ago. I feel like it was just yesterday that I was where you guys are sitting in today. So I feel like AI is quickly changing. So if you feel like you need to catch a break and take a look back at what has happened in AI, this is the talk for you. So we're going to cover at a high level what has been the different developments related to AI and language. So basically, this is the agenda for today. We're going to cover the different decades until we reach today and the future. So let's start with the 1940s and 1960s. So one of the first applications, it was not the first, but one of the first applications of what you would consider somewhat AI was in the 1960s. It was this program called ELIZA. It was an early natural language processing program that simulated psychotherapy conversations. And you might be wondering, how did it work? Did we have machine learning back then? Not quite exactly. It worked with pattern matching and substitution rules. So for example, if a user would say, I feel X, then the machine would pick up on that and then say, why do you feel X? So if the user said, I feel happy, then the algorithm would say, why do you feel happy? But the issue with that is that if the user says something like, I feel cake, then the algorithm would say, why do you feel cake? Or if nowadays you ask ChatGPT, I feel cake, and I tried it last night, ChatGPT says, oh, that's great, cake is awesome. Can you tell me more about why you feel like cake? Like, are you craving cake? You just really like cake? What is going on there? So it's able to pick up more on the actual context. Where here, it was just looking at patterns. This is not scalable, it was very early days of AI, so of course, what are the limitations? It can't generalize. So for example, we generalize all the time, even if we don't realize it. So if you've seen a spam email that says something like, I'm the prince of Nigeria and I'm gonna put some money into your bank account. You've seen thousands of those emails, you know it's spam. Even if the person that sends it changes it to I'm the prince of Azerbaijan, even if you had never seen that combination, you're able to pick up, oh yeah, like it's a scam. But when you use patterns, you can't generalize. So that's the big breakthrough of machine learning, that is capable of generalizing from a training data set. It's not learning patterns, it's not memorizing, it's learning from generalization. And of course, the other limitation is that it misses meaning and intention. So the hallmark of intelligence, whether it's human intelligence or artificial intelligence, is not that it's capable of memorizing, but the ability of generalizing from limited experience. For example, when you have a kid and you want to teach it what a dog is, you're not going to sit with the kid and say, well, a dog is a mammal that has 4 legs and 2 eyes and so on, because then the kid wouldn't be able to generalize. What if maybe you go to a shelter and you see a dog that had an accident and it only had 3 legs? Is it not a dog anymore because it doesn't satisfy the definition? You don't do that. You just show the kid pictures of dogs and the kid is able to generalize. That's the same thing that AI does nowadays. You show it a few examples, well, not a few, usually it's a lot of examples, and it's capable of generalizing. So models in machine learning work with numbers. And you have to make sure that the numerical representation of the world is good, because even if you have the best model ever, garbage in, garbage out. So you have to make sure that you're working with good numbers. So if you're working on a model to predict how much investment you're going to get, and one of your features is revenue, that's fine. It's already a number. Maybe you want to do some scaling, maybe you want to do something to that number, but it's already a number, so that's fine. What if it's an ordinal feature? You want to predict someone's income, and one of the features that you have is their education level. Well, since it's a categorical feature that has some order, then you could just say high school 1, bachelor 2, master's 3, and so on. If you have categorical features, it's not quite as straightforward, because you don't want to say, let's say if it's colors, red, green, and blue, you don't want to say that green is 3 times more than blue. You can just assign numbers. So you would do that numerical representation, something like this. That way you capture each one of them. You can also work with unstructured data. So for example, with images, it's somewhat straightforward because images are composed of pixels, and each pixel has a numerical value that represents how much of that color you have in that specific pixel. So at the end of the day, it's just a matrix full of numbers. So you can pass that through your models. But what happens with text? What can we do with text? So for example, how do we represent spring in a numerical way? Maybe some of you would say, well, let's just give numbers to all the words, and then spring is word number, I don't know, 7,255 in the English language. Well, that doesn't work because maybe most of you are thinking of spring this season, but if you assign it the same number, then you have like spring, the coil, so you can't do it that way. So if we're trying to get machines to learn the way we do as humans, we have to ask ourselves, how do we as humans learn the meaning of a word? So I want to do a quick exercise here. I want to pause for like 10 seconds, and I want you to picture something in your head when you see the word queen. And then maybe some raise of hands, like what did you picture?
Queen bee. A bee.
A bee.
Chess piece.
A chess piece. Any other?
A monarch.
A monarch.
A dry queen.
A dry queen? A drag queen? Oh, I love that.
A band.
A
The band.
Oh, Queen, yes, the music band.
Same.
Same. So that tells me a lot about your experiences and the type of data you've been exposed to, the type of newspapers you've been exposed to, the people around you, how you've grown with. So yeah, if you come from the UK, you would think of probably the Queen of England or a monarch. I'm from Colombia, so of course I have to think about the queens. And since we have a room full of data scientists, I figured everyone here was super smart, so maybe many of you were thinking of the queen in the chess game. And in the past, I've gotten some people saying like a queen mattress, like so that maybe tells me that they move a lot. But yeah, anyways, we learn from experience, from the data that we consume. The good news is that machines can also learn from experience. And you might be wondering, but how? Didn't you say that we needed numbers? What do you mean that machines learn from experience? So now I'm going to pretend all of you are machines, and I'm going to train you using only 4 documents. So what is Tichiniki? Don't look it up. Does anybody know what Tichiniki is? I see confused faces. That's okay, because machines sometimes are confused, and now you're machines. So the first document. After work on Friday, a few of us went out for some Tichiniki to relax. And I already hear some rumors here in the room. She brought a bottle of Tichiniki to the party, and everyone loved it. And then I see some people already like, yes. He drank too much Tichiniki last night and had a headache this morning. During the holidays, families often celebrate with food, music, and Tichiniki. I ask you again, what is Tichiniki? A drink? Tequila? So yes, it is an alcoholic beverage. And it only took me 4 sentences. I feel like it only took me 1. I heard some rumors here in the side of the room. So now imagine if you're giving the whole human intellect to AI and is exposed to all the books that have ever been written, all the Reddit posts, all the Facebook comments. So it's capable of learning from experience. But again, I still haven't answered the question about the numbers. So how would this work from a numerical perspective? Because models work with numbers. So then we get into something that is called distributional semantics. The meaning of a word can be understood by the company it keeps. That's exactly what we just did. So here are some other sentences. A bottle of Tichiniki is on the table. He avoids Tichiniki when he has to drive. We made Tichiniki with grapes. Not everyone likes Tichiniki. But imagine if we instead had blanks and we had these options: Tichiniki, motor oil, tacos, and wine. So I'm just going to create a quick table, and I'm going to give it a 1 if the sentence makes sense, and I'm going to give it a 0 if the sentence doesn't really make sense, like you don't expect to see that it's written somewhere out there. And of course, it's a dummy exercise, so don't think about it too hard. So with Tichiniki, we already saw that it works for all the sentences, so we're just going to put ones all across, but let's do motor oil. So a bottle of motor oil is on the table. That sounds reasonable. Well, I saw a no here. Reasonable? Not reasonable? All right, so I think it's reasonable. Maybe there's a bottle of motor oil on the table. The next one is he avoids motor oil when he has to drive. 1, 0, 0. Let's see, thumbs down. So let's give it a 0. It's kind of concerning. Like if you're gonna drive, you hope your car has motor oil. But anyways, we make motor oil with grapes. 0. Not everyone likes motor oil. I also think it's a 0, like it's a weird thing to say, even though it like grammatically makes sense, but I don't think people would say that. Let's do it with tacos. A bottle of tacos is on the table. Yeah, clearly 0. He avoids tacos when he has to drive. unless he's like, I don't know, cheese intolerant or something like that. But yeah, generally it's 0. We make tacos with grapes. So we have a Mexican in the room, 0. Okay. The expert has spoken, it's 0. Not everyone likes tacos.
0.
So, 1, like people could say that. How could they not like tacos? Well, that's a conversation for a different day. And let's do the last one. So wine, a bottle of wine is on the table. That makes sense. He avoids wine when he has to drive. I hope so. So 1. We make wines with grapes. Yes, we're California, so yes. Not everyone likes 1, so that's a 1. So now we've built this table. What do we do with this table? So some interesting things start happening with this table. So for example, let's look at this column, the first column. So the first column is kind of capturing things that can be put in a bottle. So tichiniki, motor oil, and wine, but definitely not tacos. Then we have something like sentence 4 or column 4 is capturing things that people like and dislike. So people wouldn't really say, I dislike motor oil, like that's a weird thing to say, but they would like tichiniki, they would like tacos, and they would like wine. And then if you notice across the rows, these 2 have the same numbers. So they have the same vector representation. So that means that tichiniki and wine are actually very similar. Maybe if we had more sentences, eventually they would differ somewhere because they're not the same thing, but they're very similar. And just to throw in some vocab, those are called embeddings. So whenever you can represent a word or a text in numbers, that's an embedding. So we created our very first embedding. So basically, we just went through the 1970s, the 2000s, and also the early 2010s. So what happened between the 70s and the 2000s? It was the era of statistical natural language processing. So it was a shift from these hard-coded rules, searching for patterns, where now we could use probability and statistics to represent the meaning of words. Word meanings were modeled from co-occurrence counts, and there were different strategies. So one, hot encoding, there was also bag of words, TF-IDF, and those were also the techniques that enabled early search engines. Google, back in the day, used to use TF-IDF to find the most relevant document to your search. So limitations of statistical NLP, you might have noticed that in the previous slide, there was a lot of zeros. And zeros don't really tell you much. So you're carrying all these zeros without meaning. They're consuming your computing power and not telling you much. So we had that issue, which is data sparsity. We also had issues with, it only had short context windows. So if you had a very long text, it would just forget it by the end. And it heavily relied on feature engineering. I didn't do it on the example, but for those methods to work, you have to make everything lowercase, remove apostrophes, remove weird characters. That way everything is standardized and you can do correctly the count of the different words that happen. But there's an issue with that. It's not the same thing if you text someone ha 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 in lowercase than ha 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 in that sounded weird, but if you text ha 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 in uppercase. So you were removing some meaning by doing that action that you needed to be able to do these techniques. So how did we fix that? We entered the early days of deep learning in the early 2010s. And in 2013, there was a paper published, Word2Vec, where neural networks were used to generate dense vector representations. Meaning, instead of having all those zeros, you had numbers in your vector, but all of them were non-zero numbers. So you had these dense representations. And the really cool thing that came out of this paper were analogies. AI was now capable of doing analogies. So we have the typical representation here, where, because if you think about it, if you have a numerical representation of a word, imagine if it was only 2 numbers. That's a coordinate system, right? So typically, you wouldn't have only 2 numbers, you would have several numbers, but you can reduce the dimension using something like PCA and put it in a coordinate system. So in this case, it's actually three dimensions. You visualize it, and then when you have these points in space, what can you do? You can compute distance. So you could say stuff like man is to king, as woman is to, and then the model would say queen, exactly. So that was mind-blowing that it could do that type of analogy. And same thing, like walking is to swimming, as walk is to, and then the model would say swam. But here we start seeing the first issues with unmonitored AI, because the model is just doing a representation of how we speak about things. So for example, you would say France is to Paris, as Mexico is to Mexico City, and it works, both are capitals. But it's not really saying knowledge, it's saying how people talk about those entities in conversation. So if you say France is to Paris, it's not gonna say US is to Washington DC, which is the capital. It will probably say New York, because people talk more about New York, the same way people talk more about Paris than other French cities. And that's fine, that's just more like, and not an error, it's just up to interpretation. But then you also had issues where you were perpetrating human biases. So for example, you would say man is to computer programmer, as women is to, and you would have hoped it would say computer programmer, but it said homemaker. And it's not like there were some evil scientist in some office in San Francisco. It was just that the model was capturing how people talk about things. So here was the first time where it became super clear that it was important to monitor the AI that was being released. So continuing, the next really cool advancement in AI and language were recurrent neural networks and some other architectures like LSTMs and GRUs, where these architectures were capable of capturing sequences and dependencies in text. So they became really good at completing the sentence. You would say something like, the quick brown fox, and then it would complete the rest of the sentence, or to be, and then the model would say, not to be. So that was another good advancement. Limitations of those early days when we started using deep learning for AI and language. There was a bottleneck. Everything was processed sequentially, so it was very slow. Everything had to be word by word, so you couldn't parallelize it. And you also had the problem of vanishing ingredients, so they struggled with very long sequences as well. So what happened next? In the year 2017, another one of those papers that if you're studying data science, you should definitely read it, which is the paper, Attention is All You Need. So this was a paper published by a lot of researchers at Google, and Google Brain. And it's called Attention is All You Need. And basically, it replaced the recurrence mechanism of neural networks with a different architecture of neural networks that had a self-attention mechanism. So I'm not going to go into the math in here, but basically the big breakthrough is that it allowed to process words in parallel. So this became really important when you're consuming big data, so you could go faster and learn faster. Now, this technology captures long-range dependencies, and it scales efficiently with data and compute, paving the way for very large language models. So I don't think when this group of researchers published this paper, they realized how much they would change the industry, and not only that, but how much they would change the world. Because thanks to that paper, then we go into the next era, which is the rise of large language models. So with the rise of large language models and this paper, the all you need is attention, researchers build pre-trained models that could be fine-tuned and adapted to different tasks. So I like to make a comparison of the biggest 2 advancements. Some people would argue that these family of models, the representation models, are more like small language models, but they're still very powerful. So representation models they encode meaning embedding. So basically, the same exercise that we were doing, just assigning a number to a piece of text, it's just that it's a number that is better, and it captures meaning much better. So the most famous model is BERT, and all its families, like Roberta, this BERT, and all of this. So a test example for this is, let's say you have a document or several documents, and it says something like, the movie was surprisingly good and the acting was excellent, and then you have to label it as this, negative or positive. So now you could use that numerical representation to be able to assign a label, whether it's positive or negative. And then we had the other family of models, the ones that everyone are excited about, the generation models. So with the generation models, as the word says it, it generates content. So the goal is not to generate that embedding, that numerical representation of text, but the goal is to actually generate text itself. So famous models, the GPTs, Claude, Mistral, and many more. There are some models that are both. There are encoder and decoder. I'm not going to cover them, but yeah, these ones are decoders. So a task example is, for example, summarize a movie review. The output is not going to be a label. The output is going to be a sentence, like, oh, the movie was fantastic, or the user thought that the movie was fabulous, whatever it is. So that's the difference between the two. And then, thanks to GPT and all the other decoder models, 2022 came along, and ChatGPT came along. So early GPTs were really good at mimicking style, but they were not very good at following instructions. So now they were able to capture long sequences of text, but they would just sound awkward. You would ask it something, and it would just not put it into like a context. It would just like probabilistically start predicting the next word or whatever you thought it was the next word. So they just sounded awkward, unnatural, and off topic. So they were still fun to play with, but they were not very useful to do anything with them. Then in 2022, OpenAI developed GPT 3.5 Turbo, which incorporated reinforcement learning from human feedback. So that's the secret sauce for the success behind ChatGPT, is incorporating that human feedback. GPT 3.5 Turbo was not the first model to do this, but the first one that was very popular. And if you're wondering how does this human feedback looks like, you might have seen it when you use ChatGPT. You ask a question, and usually it's at the worst time when it asks you, which answer do you think is better? And it shows you two different answers. So then right there in that moment, they're collecting human feedback. There are other moments where they can collect human feedback, but that's collecting from human feedback from the end user, which in this case will be you. And this marked a shift towards usable assistants rather than just models that would spit out text. It felt like they were actually useful. And of course, it was a very big impact in the industry, in the world. ChatGPT is one of the companies that acquire the most number of users the fastest, so 1 million users in only 5 days. The only app that acquired users faster was Threads, but I feel like that doesn't really count. So ChatGPT was the first one that acquired that amount of users in just 5 days. That was how shockingly good it was. And it was the first time that the public had direct access to AI. Because before, if you wanted to use AI or play around with AI, you had to be in a program like this, in the master's program, in a PhD program, working for a big lab in the industry. Normal people didn't have access to advanced AI, but ChatGPT gave access to most of humanity advanced AI. And I say most of humanity because I went to a country where ChatGPT didn't work, so not everyone has access to ChatGPT, but you get the idea. It was widely adopted by the general public. So then that brings to today and the future. So there are a lot of exciting developments. We have agents, we have multimodal models, we have constitutional AI, So I could easily just like spend a semester talking about the different things that are happening in AI, but I'm gonna focus on evaluations. How do we make sure these models are aligned? And it's not something that I say, it's something that is really hot in the industry right now. We can see people saying stuff like, writing evals is going to become a core skill for product managers. It's a critical part of making a good product with AI. Then someone from Anthropic said, if there's one thing we can teach people, is that writing evals is probably the most important thing. The best AI product leader I know makes it a habit of saying taste in his differentiator publicly, but behind the scenes is just ruthless evals. Evals are surprisingly often all you need, and you get the idea. AI evals everywhere. So let's talk about evaluations. If you can't measure it, you can't improve it. And that's a principle that applies in machine learning, that applies in businesses as well. So from the business perspective, you have KPIs. You have to have KPIs to track what your business is doing. And because you can measure it, you can improve it. You can see if you're doing good. If you're not doing good, what do you need to be doing to be good? Same thing with machine learning. We evaluate our models. We need to measure how they're performing so we can improve them. So with representation models, the ones that I mentioned earlier, it's a little bit easier. And I put easy in quotes because if you do machine learning, you know that there are some challenges in there as well. But you can evaluate these with traditional metrics. For those of you that don't come from a machine learning background, basically you're asking, did I get it right or did I get it wrong? Is it positive? Is it negative, this review? Did I get it right? Did I get it wrong? So you can look at accuracy, you can look at precision, you can look at recall, F1, all these different metrics. And they're straightforward because you just count how many ones you got right. But then what do you do with generation models? If you ask ChatGPT, how are you? It's gonna say something. If you ask again, it's gonna say something else. It's not always gonna give you the same answer because it's probabilistic, not deterministic. But not only that, well, the how are you answer question is somewhat easy, but if you're asking something more complicated or something that is subjective, how do you know if your model is doing good? So it is much harder to evaluate because the outputs are open-ended text. And some people, when the GPT models came out and all the different generation models came out, they proposed metrics like blue and rouge. So how does blue work? Basically, they count how many words overlap from a standard answer. So if the answer was, the standard answer provided by a human was something like, the movie was excellent, and then the LLM says something like, the movie was very excellent, there's a lot of overlap, so it says, okay, it's good. But that has an issue because the model could have said, I find this film fantastic. There's zero overlap there, but it's still conveying the same meaning. So blue didn't cut the mark. So generation models are forcing the field to rethink AI evaluations. And this is a hot topic right now. There are many different strategies coming out every single day. But before I get into some of the more popular strategies, let's talk about why evals matter. So I was saying, well, if you can't measure it, you can't improve it, but it can have real big bad consequences for people. So the biggest one, financially at least, was with Google. So Google released the Bard. It was supposed to be a competitor of ChatGPT. Now I think it's Gemini. They just renamed it to that's how bad it was. They had to rename their model. And basically what happened is in one of their promotional videos, there was a question about what is one cool thing that the James Webb telescope did? And then Bard said it was the first telescope to photograph a planet outside of our planetary system, which is not true. It was a different telescope like 20 years earlier. So quickly, all the astrophysicists noticed the error, started tweeting about it, and it was so bad that the shares for Google lost $100 billion after that fiasco, just for a bad promotional ad. But also because the model was not accurate. So you can see how bad it can get. But if you're not convinced, or maybe like, how does this happen? Like, it's Google, right? Like, how did this happen to Google? The thing is that since the answers are open-ended. You can test your model with a few examples, and you can be deceived to think that it's good because you happen to ask the questions that the model knew really well, it said it well. Also, the model is probabilistic, so maybe when you ask, they give you the right answers, but if you ask again, maybe it hallucinates. And the issue comes when you bring the model into the real world, you have real users, and it fails on edge cases or a more diverse pool than the people that you're working with. Try the model and it breaks. So you don't want that because you don't want to have frustrated users and you don't want users to not adopt your product. And also, once the trust is gone, it's really hard to recover it. So even if you improve your model, Google had to change the name from Bard to Gemini because the reputation damage was too big. So this literally can make a product thrive or die. So evals are very important. So as I was mentioning, this is a current open research problem. If you really like this topic, my recommendation would be go on archive.org every morning and search for papers related to AI evils and read about them because they're literally happening as we speak. And also you're in the best place in the world to be in. If you see a researcher that published this, chances are they're in San Francisco and you can just reach out to them and maybe run into them in one of the meetup events. So the field is moving toward hybrid approaches that combine automation with human judgment. So one of the first approaches, and this is more like for like math results or code results, not so much for just general language, is to make sure that it works. So for example, if you're generating code, either it runs or it doesn't run. So it's easier to evaluate that something that is a little bit more abstract. So it's a deterministic check. You run the output and you see if the code actually works. It's more precise. You can reproduce it and it's more scalable. But of course, it doesn't escalate well with some things that are more abstract. So what do you do when you're working with things that are more either abstract or subjective? One alternative that is very popular are LLMs as a judge. So how does that work? So basically, you get a different LLM. So if you're working with, let's say, GPT-5, you then work with Claude, and then you make Claude judge GPT. So basically, it's a quick way to generate labels in an automated way. That way, you're not working with humans generating these labels. And of course, it requires some initial setup of the LLM that is acting as a judge with some labeled examples so you can get a sense of like what's right and what's wrong. Also, it's an LLM, so it's non-deterministic, so you have to have a huge volume of data. That way you can rely a little bit more on the results. More reliable than traditional metrics like Blue, but you still have the problem that it's only as good as the judge model. So it becomes a problem of the chicken and the egg, like who's gonna be the judge of the LLM that is a judge? Like you get another LLM to judge that one, and then you get another LLM to judge that one. So I've seen some really creative like solutions to this in the recent papers. Some people are using the concept of wisdom of the crowd, and they just get different LLMs to evaluate something, and then they use the consensus of all the LLMs. Or sometimes people use the same thing, and then they have like another LLM to aggregate all the results. So people are actively researching on this, and if this sparks your curiosity, maybe you can think of a different clever solution, like why don't we try this LLM this way, and it could become a paper. The other strategy, of course, is using actual humans, so human evals. So humans, just you make them do something, whether it's like rate outputs for quality, for correctness, for usefulness, for tone, and they're a gold standard for nuanced judgments as well. So it also depends on your application. If you're working on a generic AI or versus like a mental health AI, you're gonna want different judgments. So you have to get those gold standards for the model. It's of course costly because you have to compensate the humans, and it's lower to scale because they're not LLMs. They're not gonna give you the input in 1 second, but they're super critical for trustworthy AI systems. So what is the current trend in the industry? Just having a hybrid approach with LLMs as judges and human evils. That way you can scale a little bit more, but you still have the human input, making sure that the judges are doing what they're supposed to be doing. So given that I work at Prolific, I didn't mention this at the beginning of my talk, but Prolific provides the human data for building better AI. So basically, if you need humans, go to Prolific, use their API. So now I'm going to focus a little bit on human evils. I'm just going to do a zoom on human evils. So what are the types of human evils? And I realize that with my accent, it sounds like humans that are evil. But no, evil. So we're not doing evil stuff here. So different human evil methods answer different questions. So you might be wondering, what kind of humans do I need? Do I need experts? Do I need normal people? So the answer is typically everything. You should have a little bit of everything. So you could have end users. That's the example I was giving earlier about ChatGPT, but it shows you the two windows. And you have to choose which one is the best answer. So you have to reflect, well, the end users are really good because they reflect real world needs, how people are actually using that AI. They take direct feedback from the actual users, reflects real world patterns and genuine user needs. The issue is that is noisy and inconsistent, because I'm guilty of this, but sometimes when I get the two window on ChatGPT, I just click whichever one because I don't care, I just want to get the result. So I'm just destroying ChatGPT's algorithm. I'm sorry, ChatGPT, but I'm very sure I'm not the only one doing this. And like, especially people from the public, like they wouldn't know. And also sometimes, even if you have the best intentions, the answers are so similar that you just kind of click one at random. So you can see how it can be very noisy, it can be inconsistent, and also it might come too late. If you only rely on end users, you don't want them to find like the bad stuff of the model. So yes, you should be always collecting this end user feedback. That way you're constantly monitoring your AI, but it shouldn't be the only input of human inputs. The other one is, of course, experts. Experts can catch subtle, I wrote technical issues, but it doesn't necessarily have to be technical issues. It's just issues of their specific expertise, whether it's medicine, legal. It doesn't necessarily mean that they have to have a degree. It could be like someone that really knows how to work forms in a specific country, and they're really good at that, so they're good at their expertise. So the assessment is done by this domain specialist. And the advantage is that they can catch subtle issues that the general public wouldn't catch. So, for example, the astrophysicists. So Google needed to hire astrophysicists as their experts before they released that model. There's an issue with this approach as well, because there's potential for expert bias. Also, another issue is that a lot of the experts most of the time come from the global north and the west. So you're representing those views into the model and not really a diverse view. And also, there's limited experts. And then you just have crowds where you want to tap into a diverse pool of participants. Why? Because then, even though they're not experts, they resemble more the real user that's going to use your app. And also, if you have a diverse pool of participants, you avoid those edge cases that maybe you didn't think of by having this pool of diverse participants. So let's see how we're doing on time. So for the last 15 minutes or 10 minutes or so, we have a human eval workflow. So if you're setting up a human eval workflow, what should you be considering? And this is just at high level. I'm happy to talk about technical details after the talk, but the first thing is define a goal. If you try to do too many things with your human taskers, they're gonna get confused. So if you wanna target hallucinations, kind of like when Google's model said that James Webb had been the first telescope to see the exoplanet, just focus on that accuracy. If you want to work maybe on the tone, you don't want your model to come across as rude, because then people wouldn't use it, then make that the task. Don't convolute all the tasks, because then your taskers are gonna get confused and not gonna give you good levels, evaluations. The other one is, of course, you have to build a data set. So this data set, you can build it a strategy between looking at the logs for the prompts, so what people have been asking to your model, and see what are the most popular things, and also thinking of edge cases. So you build this data set, and then you choose the evaluators. So depending on the task that you're working with, maybe you want end users, domain experts, or diverse participants. Then you have to calibrate evaluators as well, because you want them to be able to give you consistent criteria by providing annotation guidelines. So you have to make sure that they understand exactly what is it that they're trying to do. So in the past, I worked with a group of humans that they were supposed to label audio data from police scanners. And well, police scanners are really difficult to understand because they talk really close to the microphone and they use police jargon that normal people wouldn't understand. So I had domain experts that were familiar with this type of data. But the issue, because I was young and naive, is that I didn't calibrate them. So some of them were using abbreviations, some of them were using different ways of annotating the data. So that's not good as well. So you have to make sure that your expectations are very clear. Related to this, I didn't put it on the slide, but also take care of your humans, because I also made this mistake. I gave too much stuff to label for these poor humans, and then they were getting tired and they were fatigued, and I was getting bad results. At first, they were like, the labels were excellent, and then at the end, they were bad. So take care of your humans. Then run the tasks, so whatever you need to be doing, like ratings, comparisons, and so on. And analyze the results. So either you aggregate them with majority vote, or you weight the consensus. And then a good strategy as well is once you have that, segment the results by type, demographic, or prompt type. So for example, you could look into things like, are younger people replying differently than older people? Should I be adjusting my model so it serves better the older people, and so on, this type of questions. And of course, you need to act on those insights. If you don't do anything with those insights, it doesn't matter. So you feed back those failures back to the model. Typically, you do that with supervised fine-tuning or reinforcement learning human feedback. So you update your set of evaluations and you continue monitoring. So this is something that never stops. You should always be monitoring your model, because there could be drift. People start talking differently about things, topics change, things that maybe were considered okay before now are not okay. Whatever it is, you should always be doing a constant monitoring of your evaluations. So with that, just like the last shameless plug. So if you ever want to work with human data, I work for Prolific. We're actually super close to here. If you guys ever want to visit the office, just let me know. It's like a 10-minute walk from here. But Prolific makes it easy to get the human data. You need to build better AI. So basically, we have domain experts. We also have a global diverse pool of participants, so whichever one you need. But my favorite part of Prolific, compared to other companies that are in the same space, is that they're API first. So I'm a coder. I love to code. I hate to talk to sales. Sorry if there's salespeople here. So it's really nice that you can just go on Prolific, get a token, and start working. You don't need to sign up a big contract, work with sales. If you want to, if you're from a company, we also offer that. But if you're just a developer, you can just get started right away. And my second favorite thing about Prolific is that the evaluations are coming in so fast. I couldn't believe it myself when I was interviewing at Prolific, because I wanted to impress the people interviewing me. So I was like, I'm gonna use the API so they can see that I know how to use the API. And the interview was on a Tuesday, and I was preparing for the interview on Sunday. And I was like, well, I'll use the API, but I don't think I'll get answers by Tuesday. Like, that's too fast. Like, are people online? I'm what is going to happen. So I used the API, and literally within 10 minutes, I had already responses back. I was so shocked. I think that was the moment when Prolific passed my interview when I was interviewing them, because it's a two-way street process, and I was like really shocked of how fast it was. So I'll close that parenthesis with a shameless plug. So if you want to keep up to date with what we do at Prolific, follow us on LinkedIn. We do a lot of events here in the Bay Area. We run hackathons, we do community events. So yeah, stay in touch, and of course, like I'm happy to be intermediate, because my university, my company, of course, is a good synergy. And then thank you so much. Let's stay in touch. Here is my LinkedIn, my Twitter, and it was a pleasure to be here. So thank you so much, everyone.
We do have a few moments for questions. So are there questions from the group?
Viviana, thank you so much for your time. My name is Chris. I'm kind of curious about the stuff that you talked about using LLM as a judge. So would you just type in, for example, if you want to check if Gemini is reliable, do you just go on ChatGPT and ask, is Gemini reliable, or is it possible to make ChatGPT have a conversation with Gemini and then make them talk, and then later on determine if Gemini is reliable?
That's an excellent question, so I'll repeat it for the group. So basically, it's a question related to LLMs as judges. So how does that actually work? Like, do you make GPT talk to Gemini? Do you just ask Gemini, is GPT reliable, and so on? So that could be an interesting follow-up conversation, and I'm shameless plug. But yeah, so there's a part of calibration. So the same way you tell your humans what you want to do and what they should be looking for, you do the same thing with the LLM via prompting. And of course, you would do it via the API. I mean, technically you could do it via the UI, but if you want to do it programmatically and it scales, you have to use the APIs. You had another question. I think I forgot it.
Oh, do you just ask ChatGPT, a person ask ChatGPT if Gemini is reliable? I thought you said you can use like another LLM to determine another LLM is reliable.
Yeah, so you can ask the other model, the judge, with a prompt to evaluate the other model. So you will work on the prompt. If you ask if it's this other model reliable, I don't think the model would know what to do. The same way if you ask a human, is this model reliable? A normal human will be like, what does that even mean? So you need to give it something very specific in the prompt. Is this model friendly? Here are a few short examples of what friendly looks like. Or is this model hallucinating? Make sure that it's saying accurate stuff. So you have to work on the prompt. That way it's going back to human evaluations. It's the same way. You have a very specific goal of what is it that you're trying to evaluate, rather than a generic question of is it reliable. But the logic is the same. You would use the judge, give it a prompt, and then use that prompt on the answer of the other model that provides. Yeah, first.
Thank you very much. Got a question. So I'm building a model that's being trained on MRI data, variants of MRI images, and I'm looking for aberrations in bone tissue. I'm making this up. And how would I use your service, right, would I do fine-tuning, or would I do weights and bias modifications? What would I do with your service if I come to you and say I need to improve the accuracy of the line?
I love that question, which is a question for Prolific. How would you use Prolific? The question is regarding MRI data, and then I have a follow-up question for you, which is, what are you trying to achieve with these images?
So the objective is to identify certain cancer forms in femurs.
So one of the use cases that I'm thinking is, for example, you are trying to create a model that predicts cancer on this MRI data. And then you maybe don't have, one of the use cases for Prolific is also to create a training data set. So you don't have enough data that has been labeled, so you could find domain experts in that specific field, and then you will get the labels from them and feed it back to the model. You could also use it for fine tuning. So for example, if you're working with a generic model like ResNet, trained on ImageNet, which is like thousands of millions of images of random things, but you want to specifically fine tune it for data to detect cancer. So then you get those labels, and with those labels you fine tune the model like ResNet, but that's an example. You could use other models as well.
And just follow up for you, just for the benefit of the group, if I am using these handcrafted labels, what actually happens technically at the level of the neural network? Would I be modifying the weights of the biases? Or what would I be doing?
It depends on the strategy that you take. So for example, the way I immediately thought about it, but it's not the only strategy, is with transfer learning. So basically you're creating another layer on top of the original model that is a fully connected layer, and that fully connected layer will correspond to the different classes of cancer that you're trying to predict, or whether it's like cancer or not cancer, whichever task it is. And then basically you're finding the biases and the parameters of that last little layer, because the other ones stay the same. It's one strategy, but you could also modify the weights of the original model. So it depends on the strategy that you want to approach.
Hi, thank you for your talk. It was very interesting. I was wondering what you think are the differences between evals for agents and for models?
That's a really good question. So most of evils right now, I was talking too much about evils. So the question is, what is the difference for agents? How do we evaluate agents? So right now, most agents are basically LLMs that have access to functions. So a lot of them could just be code checkers to make sure that the code is correct. But I would say it's a combination of them, because you do the code check to see if it run correctly. But I would also get some experts that know how to code to make sure that it's not doing some mischievous things in the back. So it will be a combination of those two. But also, a little bit off topic, that brings me to the next era of AI, which is the experience era of AI, where we let the agents interact with the world rather than being fine-tuned on human preference. So the evils that way are going to be more, rather than giving feedback to the model, just seeing how people would actually react. So for example, you let, I don't know, an agent invest in the stock market, and then it loses all your money, then you will be very upset about that. So you wouldn't, the feedback to your model, to the model wouldn't be like ranking or something, but your reaction. Like maybe you remove money from the account, and then the model learns like, I messed up because now I don't have money. I should have invested better. So really exciting stuff coming up ahead. The era of experience just started. So yeah, really excited to see what's going to happen in the field.